Good day everyone around the world. Let's do a very important lesson. Just pay attention to this video. If you have anything that you are doing, just relax because we explain very important aspects about laptop repairs. Because from the comment section, I've seen 80 to 90% of the comments are about laptop repairs. People there seems to have lack of understanding on certain things about laptop motherboards. It seems as if fixing laptops is like a big deal. People they're asking, my laptop is behaving like that. What can I check? My laptop is doing this and doing that and doing that. It's like an everyday story. So I'll take this moment to explain further about motherboard, about how the laptop motherboard they are working. Also, by the end of this video, you know the kind of faults that you have to pay attention to, the kind of faults that you are most likely to fix on laptop motherboards, the faults that will give you hope, the faults that doesn't give you hope. So with me here, we have this e-machines. It's under the category of ESA laptop. No, this is not for repair. I just took this laptop. Yeah, that's the laptop. I took it from my junkyard. It's working. We'll use this for all the experiments that we are going to do. So it has been a while since we started fixing laptops, motherboards. But the first question that you have to ask yourself, where are the similarities on all motherboards? Like if you put a ESA laptop, ESA motherboard here, a Dell, Lenovo, Toshiba, a MacBook motherboard, what are the similarities on all those motherboards? What are the common things that you found on each and every motherboard? That's the most question that you have to ask yourself. Obviously, we have some components, we have some ceramic capacitors, we have some MOSFETs, we have some switching power supply. Actually, all the laptop motherboards, they have switching power supplies. That's the most common thing. So you have to grab the concept of how a switching power supply is working. How the 19 volts is being stepped down to 1 volt for the CPU, to 1.5 for the RAM, to 5 volts for the USB, to 3.3 for the startup chip. You have to know all those certain things. In other words, we are talking of knowing the basics of how the laptop motherboard is working. And if you know the basics, 100% sure you can fix 70% of the laptop that came in at your workshop for repair. But here we'll focus mostly on the hardware problems. The hardware problems that we are mostly likely to have. So what is what is our starting point? Okay. First of all, let's plug the power supply to this e-machine. This is not a repair. It's taking 10 milliamps. Yeah, that's the laptop. The top cover and the keyboard is not working. It's not there. That's less important. All what we have to pay attention is to see if this is going to help us. I I press the power on, and this is working. As you can see, the motherboard is working. You can see some writing. Okay, fine, and it's taking 1.2 amps. So here we have a working motherboard. We have a working motherboard. We don't want the screen at the moment. I just wanted to show you that this is a working motherboard. So here we have a motherboard. That's the motherboard. We have so many components. We have ceramic capacitors. We have some MOSFETs. We have some ceramic capacitors. We have some MOSFETs. We have the driver. We have the startup chip. We have AMD PCH. Okay. So this is a working motherboard, right? So what are the faults that are likely to occur on this motherboard? The most common fault that you find on a dead motherboard, most common faults, the ceramic capacitors. If you check here, we have MOSFETs from 2 here, like 4. We have those ceramic capacitors. They are dying so many times. And those ceramic capacitors, you find them on every switching power supply. And when one is on short, the whole motherboard is dead because they are in parallel mode. So what I will do, let's kill this motherboard. We need a lot of amps, like 5.2, 39 volts, 5.2. Yeah, my power supply is stretching to 60 volts. So let's kill this. Let's kill this. We want to short a ceramic cape. Here we have a power supply. So let's play with the power. Let's see now. Diode mode. Let's check with continuity. No, we didn't achieve what we want. We want to short this motherboard. Okay. Now you see, on those ceramic capacitors here, I'll put one probe on the ground and go close to my webcam. If you check on this side, it's beeping. This side is beeping. So we have just killed this motherboard. We killed this motherboard. Now let's go back to our normal 19 volts, even 2.2. Let's try to power on this motherboard. Plug in the power supply. On. What? Three amps, fine. Let me look for the right tip for ESA. That is an interesting subject. When we simulate faults, we destroy the motherboard and try to fix it. It's taking it's taking 10 milliamps, and in this scenario you say everything is fine, but nothing is fine on this motherboard because already we've queued it. Checking on the 19 volts power line, it's not even there. Here is there, 19 on the charging port. Here is there, it's there. That's the output of the first MOSFET, and on the output of the second, we don't have voltage. Diode, the output is beeping to ground. So this is the most common fault on laptop motherboard. If you see the second MOSFET is beeping to ground, maybe you can go on a microscope. Microscope. Okay. So here we have those MOSFETs in serial mode. We have those MOSFET in serial mode. This is the first MOSFET here. It's coming here. It's coming here. Here's the output. Checking the output with ground. I'll stick one probe on the ground. It's beeping to ground. So already we have created a short. This motherboard, I can see here on the MOSFETs we have some liquid damage, but still it was working like that. Why this motherboard is not working? Because here here we have a short. Those ceramic capacitors, we just short those ceramic capacitors. So here the 19 volts power line is not present because the ceramic capacitors, they are connected on the input of every switching power supply, and when one is on short, the 19 volts, the motherboard won't receive 19 volts, and here we have the ENE chip, won't receive 3.3, because in order to have 19 volts, to order to have 3.3 always for the startup chip, the 19 volts power line has to be okay. So you might have this kind of fault. You might have this kind of fault, and if you have this kind of fault, the motherboard is not turning on. What we have to do, let's take out the shorted capacitors. Let's take out the shorted capacitors. I took both of those ceramic capacitors. And now I'm sure the short is gone. I'm sure there's no more short. Yeah, the short is gone. So this is the common fault. Ceramic capacitors, they are dying so easily. And those ceramic capacitors, they are there to prevent spikes, because the power from after these two MOSFETs, the 19 volts is going straight on those ceramic capacitors into the switching power supply. So yeah, capacitors, they are dying so easily. Here on the input, what is most likely to fail are those MOSFETs. If you see the first MOSFET is not passing the 19 volts, check the second MOSFET. Maybe you have a shorted second MOSFET from drain to source, you have a faulty BQ chip, or it can be anything. Or you might have a short somewhere on the motherboard. But in most cases, if the 19 volts is shorted to ground, the power is stopping on the input of the second MOSFET. The second MOSFET, on the input you have 19, on the output you have 0. Or you might have 2 point something volts, you might have 1 point something volts. Here we must know what you are capable of fixing. We have this PCH on the other side of the motherboard. We do have the CPU. On some new model of laptop, this CPU is not removable. And here we are lucky both the CPU is under the socket. If anything goes wrong with the CPU, you can take out the CPU, you replace it. This is the old style, but it was a good design. I like this new model, these new motherboards, these ones, where the CPU, PCH, GPU is on one chip, single chip board. And the processor in this one is dying so easily. Mostly the PCH is dying inside the CPU. So here we have the GPU. The GPU can be faulty. And when the laptop is coming on with no display, in that case, on these old motherboards, you can try to reheat the GPU as a temporary measure, maybe to retrieve some information from the laptop. You might be lucky for the laptop to post on the screen, but in most cases, when the GPU is dead, it's coming on with no display. So the GPU can die, this processor can die. In a way where the processor is dead, it's hard to say. The laptop can behave in any form. Maybe can be completely dead, can be half dead, like it's coming on, you can see some lights, you maybe try to do the BIOS reprogramming, you try other things and still it's not working. Maybe the CPU is dead. So let's see what is our next step. But before I go to the next step, let's see if this motherboard can work. Now it's taking 11 milliamps. Pressing, you can see the LED. It's taking 900 and it's working fine, even without replacing those ceramic capacitors. So that's why on some of my videos, I took out the capacitor, I never replaced it. Why? Because on the next power supply, if you check here, we have some ceramic caps. If you check on a different power supply, we have some ceramic capacitors. Here we have ceramic capacitor. If you take out the motherboard on the other side, here it's a switching power supply, coil, 2 MOSFETs, ceramic capacitors. Here, coil, 2 MOSFETs, ceramic cap. So that is the most common fault when the 19 volts power supply is absent. And if the 19 volts power supply is okay, what you have to check first, to check second, now the motherboard is off. Now the motherboard is off. Checking on the output of the second MOSFET, we have 19 volts. What is the next step? The next step, we don't need this frame at the moment. The next step is to check the 3.3. And on the last pin of the BIOS chip, which is here, we must have 3.3. If we have 3.3, it means on these coils, if you check on these coils, one is 5 volts and the other is 3.3. You see? 5 volts, 3.3. So here is the issue. When the 3.3 volts power supply is off, can be because of many reasons. Let's see what driver do we have here on the 3.3 and 5 volts power supply. What driver do we have? We do have, this is an old motherboard. This is an old motherboard. And what is here is TPS 51427A. That is the driver. And here, that's why we were checking on the BIOS chip. This motherboard has some liquid damage, but it's working like that. Because here, we have another liquid damage. So, this driver can be faulty. Or if you check, because here we have 5 volts, we have 3.3, I'm sure there must be VREC 3 and VREC 5. VREC 3 and VREC 5. The VREC 3, if you check, if VREC 3 is shorted to ground, and you ask yourself, why do you have a short to ground? Let's see here. This is the first output, 3.3. Second output, we have 5 volts. Third output, this is probably this is the VREC 3. Was from this pin, is going to the last pin of the BIOS chip, is going to our E.N.E chip. So if we have 3.3 here, we must have VREC 5 volts. This is the VE, probably. This is the VREC 5, maybe, because we don't have schematics. So if we check on the E.N.E chip, we must have 3.3. Yeah, we do have 3.3. So this can be fault. You know, the idea of this video is just to simulate some faults and see how the motherboard is behaving. So what is most likely to fail? The E.N.E chip. This is shorting many times. If you have 19 volts but you have 3.3, check the driver of the 3.3 volts power supply. What I'm doing, I'm looking for the data sheet for the chip. I'll locate the VREC 3 and I'll come with my 3.3 from the power supply. I'll lower this 19 volts to 3.3 and supply my 3.3. And if you do something like that, what is on short will start to heat up. What is on short will be taking too much current. And by taking too much current, that component will be heating up. In most cases, if it's not the driver, you will find this startup chip will be heating up. So if you go on the desktop, here, what did we say? We have some ceramic capacitors. Don't worry about the handwriting. Ceramic capacitors. MOSFETs, especially the input MOSFETs, they are dying. But you can have a MOSFET on a different power supply can go dead. EC chip, EC chip, EC chip can be on short. We might have the 3.3 regulator, 3.3 regulator. This can be on short. In the worst scenario, where you can't do anything, you have a dead CPU, like on all-in-one motherboard. You might dead GPU. On the GPU, the laptop is coming on, but no display. On the CPU, you might have different kind of behavior. We'll see. We'll try to simulate this CPU power supply, the vehicle, and see how the laptop behaves. On the BIOS, I never found like a dead BIOS chip. When I say dead, I say like a shorted BIOS chip from one pin to the other. But what I found was the corrupt firmware from inside this BIOS chip. The firmware is getting corrupt so many times. The firmware from the BIOS chip is getting corrupt so many times. So now what we can do, here, we have a BIOS chip. We do have a BIOS chip, and I'm sure everyone understands or knows what a BIOS chip is. So I will take a BIOS chip. A BIOS chip is a bigger MOSFET in terms of size. In most of motherboards, you find 1 or 2 BIOS chips, or it can be 3. Because some chips, especially on modern model of motherboards, you might have BIOS chip for the PCH, BIOS chip for bigger chips. Yeah, that can happen. What I want to do, that's the BIOS chip. We took out the BIOS chip. Let's put it on safe place. Let's take just a random motherboard here. Let's take a random motherboard. Where's the BIOS for this motherboard? We want to see what will happen in the case that let's put a wrong BIOS chip here. This motherboard, this is a Dell motherboard. So we took out a BIOS chip from a Dell motherboard and we put it here. And my question is, why did we do that? I'll explain you why we are doing this. So here why did we do this? We are trying to we're trying to load the wrong firmware for this ENE chip. Let's see what will happen with this motherboard. Let's see what will happen with this motherboard. It's taking 9 milliamps on. The motherboard is not responding. So here, maybe if this motherboard was in full casing, maybe we're going to see some lights just stuck, like you have dead current. If you are to check some voltage, if you are to check the voltage, we do have 3.3. You see, you have 19 volts. Here, you have 3.3. Here, on the other side of the motherboard, the 3.3 volts power supply is on. The 5 volts power supply is on, but you can't turn on the motherboard. This is a most common fault on laptop motherboards. You have 19 volts, you have 3.3, you keep on pressing the power on button, but the motherboard is not responding. What is my next step? What is your next step? The next step, what I would do, if I see something like that, I'll check the lights. If I have some lights, I'll pay attention to the behavior of the current consumption and the lights. If on HP, if we have the flashing light, probably you have the corrupt firmware from the BIOS chip. What we have done right now, we are trying to power on this motherboard with the wrong firmware. This is a Dell firmware. This is the firmware from the Dell motherboard, but we are forcing it to turn on this E-machine motherboard, which is impossible. Same like when we have a corrupt firmware from the BIOS chip. You keep on pressing the power on button, the motherboard is not responding, or it is responding but it's not posting anything on the screen. In any of those scenarios, you have a corrupt firmware, you have to reprogram the BIOS chip. Or in some instance, you might have maybe a fault switch. So what you do in that scenario is to check if you have any voltage on the switch. We have 17. We have 17. I don't know whether this, because there is meant to be 3.3. We are not here to fix, so I don't stress myself. There on the switch is meant to have 3.3 volts. When you press the condition to start the motherboard is to send that voltage on the plus to ground once, and that will turn the motherboard on. Okay, so you might have a fault switch. If the switch is good, this guy, you know, the startup chip, yeah, that startup chip can be dead. You might have a dead E.T.C chip, and you have to confirm that before you replace this to see if this chip is dead. You go and check the VREC3. In most cases, around this chip, 3.3 and 5 volts regulator, we have some ceramic capacitors. Just check those capacitors for short. Maybe we have a shorted startup chip. So yeah, so in most cases we are fixing faults which are related to power. On the digital side, probably you can't do anything. Huh? You can't do anything if you replace the 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 the, the startup chip, and maybe you have problem with the HDMI or on the USB. You replace the 5 volts regulator. Uh, the USB physically is not damaged. Yeah, maybe you have some chipset problem. You have the processor, and you can't do anything. Yeah, and that is the the first thing that I would do when I receive a job. I'm assessing the chances of bringing back that motherboard to life. If I see the chances are low, those are the jobs that I would do on my free time. Because honestly, the way how I'm working, I'm receiving like 10, 15 laptops on every day. So after all, I'm be hunting for money. I will do those simple jobs first. Whatever job that I know would take me too long, I'll do it after. That's according to me. Obvious, everyone on his or a workshop, he has the the way how you are treating some repairs. Myself, I'm doing simple repairs first, the hard ones or those confusing ones at a later stage. Huh? So now, now let's put back the original BIOS chip. Let's put back the original BIOS chip. BIOS. So what I found, even when I was checking on the AliExpress, I found a lot of suppliers, they were selling BIOS chip. But to be honest with you, during my entire life of doing repairs, I never found like a dead BIOS chip. I never found a dead BIOS chip, and people, they are selling BIOS chips. Huh? Our BIOS chip is in place. What I would do, uh, here we have the RAM power supply. If the RAM power supply here, next to the RAM, that must be the RAM power supply because the tracks, they are going on this RAM socket. So on the RAM power supply, if the RAM power supply doesn't have voltage, obviously in most cases the laptop is coming on with no display. Or if here we have some open MOSFETs on the RAM power supply, if the high side MOSFET is open, and what I found mostly, the high side MOSFET was open and was sending 19 volts to the RAM, and you see a laptop is coming on with no display and the RAM is getting very hot, because instead of 1.5 going to the RAM will be receiving 19 volts, and in most cases that RAM obvious is going to die instantly, because this RAM, they are meant to work with around 1.2 to 1.5 volts, or it can be from to 2.5 depending with the laptop motherboard. Like gaming laptops, I found 2.5 on the RAM power supply, on the output of the RAM power supply. So what I'm interested to simulate here is the CPU. I want to see whether this motherboard, okay, before we go to that stage, let's see if we still have a working motherboard. Maybe we just kill the motherboard. You know, don't do this stupid mistake if it's a real repair. Let's go on a microscope. So what I've done wrong here, anyone who is noticing my mistake, we put the BIOS chip the wrong way. I never recognized the mark of the BIOS chip. Okay. I'm sure I didn't kill anything on the 3.3 volts power supply. Because if I kill, this has, we have a mark, so this has to be like this. Fine. Let's cool the motherboard. So now we've put the BIOS chip the right way. Let's see. Where's the screen? Let's put the screen back and see if we still have a working motherboard. That's very important. Power on. The motherboard is on. Yeah, you can see a big E. We still have a working motherboard. You can see the writing. Fine. So we're gonna kill this motherboard further. Let's check out the heatsink. We're gonna kill this motherboard further. Because we are only touching on the areas where most likely to have a fault. If you check on this motherboard here, we have MOSFETs like 4 ceramic capacitors, another MOSFET like 6. We have ISL, which is the driver, and here we have 2 coils. This is the vehicle section. What I'm going to do, let's go on a microscope. Let's go on a microscope. Okay. Let's take out, let's disconnect this power supply. Let's disconnect this power supply. I'm taking out this coil. Come on. Oh, the coils are melting. Why? Okay, that's not a big issue. We took out the coils. We took out the coils. That means there's no voltage which is going to the CPU. That's what it means. We want to see how the motherboard will react with no voltage on the CPU. Is the motherboard coming on or not? That's what I want to see right now. So without the CPU voltage on, it's taking 11 milliamps and the motherboard is coming on. Okay. I want to see if we have anything on the screen. I want to see if we have anything on the screen. That's interesting to see that this motherboard can work without the CPU voltage on. It's coming on. You can see the LEDs, they are on, but we have nothing on the screen. Basically, we have nothing on the screen, and it's taking only 109 milliamps. Why we don't have anything on the screen? Because the CPU doesn't have power. We don't have anything on the screen because the CPU doesn't have power. We disconnected this power supply both from this coil. They are on the output. They are connected on the output. And when we disconnect this power supply, obvious the processor is not getting the required voltage, and the motherboard is coming on, but no display. So on the issue of coming on with no display, you might have problem also with this vehicle power supply. So that's what you have to check. You have to check the vehicle. You have to check the GPU, which I assume is this one, next to this small chip, which is the GPU, the AMD processor. Okay. So that's the thing. That's the thing about faults. That's the thing about faults. So a coil is a wire. A coil is a wire. Diode mode. A coil is a wire. So what we can do here, we can go on Microscope. We can go on Microscope. We have that resistor which will move a slight bit. Where is that? Here. So what I want to do, I want to put back this resistor on its original place. So since a coil is a wire, what we can do, here we are learning, and it's good to do some experiments. I'm happy because this is our motherboard. This is our motherboard. If anything goes bad here, there's nothing to regret. A coil is a wire, so we took out the coil. We can replace the coil, but since a coil is a wire, I'll use a wire here. Everyone wants to see if this motherboard is going to work. Is going to work with the wires, right? Who is waiting to see? Where is my cutter? Where is my cutter? Who is waiting to see if the motherboard can work without coils? Because what we want voltage on the CPU. So we have to eliminate all those coils. That's good. Let's cut here. Yeah. So if we have problem with the vehicle power supply, some model of laptop, the laptop won't even come on. Especially if we have problem with the driver. But if we have problem with the MOSFETs, you know, the DRMOS, on some new model laptops, the laptop will come on, but no display. Or in some instance, the laptop is not even coming on at all. So now the motherboard without the CPU coils, do we have a working motherboard? Do we have a working motherboard? That's very important. Because people, they are struggling outside there, especially when it comes to laptop motherboard repair. Seems like the hardware, laptop hardware repairs is a big issue. Now it's taking 11 milliamps. Pressing the power. Okay. The motherboard is still staying on, but we have nothing on the screen. So why we don't have why we have nothing on the screen? Do you know why? Why is not posting now? Why do you think it's not posting? Because those wires, they are not carrying enough current to the CPU. This is an old model of laptop motherboard. So the only way is to replace, is to take out those wires and replace with the coils. So let's take out the wires. We are here. Let's take out the wires. That's good to experiment. It's good to experiment. So you can't use a wire to replace a coil, especially on laptop motherboard. But I've done this on TV motherboard and the TV was still working fine. But here my theory seems to be inapplicable. So let's look for coils. Coil. Let's look for coils. Coils, exactly the coils that we want. Okay. I'll use my I want to use this heavy duty water because we don't want to waste time. Uh, I took out the nozzle because I want it to be fast. Okay. Coils are out. Let's go where they are supposed to be and do the same thing. Good. So our coils have been replaced. Uh, this one doesn't look okay. The other one looks okay, but not the other one. So now we've replaced the coil. Let's wait to cool down the motherboard and then we'll continue the lesson. Now let's see. Let's see now after replacing the coils. So generally you can't replace a coil with a wire. You can't. Especially on laptop motherboard. We just proved the theory that it won't work. Power supply plugged in. On. Where's the power on? Here. On. No. I can't even turn on the motherboard. Why? Anything bad? Anything bad we have done here? Or is this connector for the switch? Okay, let's plug it here. It's taking 11. And it's not working. How is that possible? Just to queue. Okay. This is the problem. 19 volts. Present. 3.3. 3.3 is no more there. 3.3. 0. 3.30. 5 volts 0. So I think we just queued the motherboard, and now the 3.3 is off. Now the 3.3 is off. So these are real situations that we face on everyday lives in repairs. You try to fix something or you try to prove a point. Now we have voltage 3 point. Now we have 5 volts. Okay. On. It's not coming on. Okay. All right. No. You know what I did? What I did, let's take out this connector. No, it's not about the motherboard. I did something stupid again. Okay. Here. Uh, I just broke this connector. And I'm sure that is the cause. Because we have like 1, 2, 3 pins. They are no longer connected. Like all the pins. Check this connector. So how did this happen? So with the tweezer, can you power on this? Okay. Now is a big problem. The problem on this switch, we have in 19 volts on this switch connector. And if you short that 19 volts, the motherboard won't turn on. 3.3, 0. Shorting third pin to ground. No, that's not the right pin. So now the story, I break this flex cable, which is going to the power on switch. So we have to try to power on this with a tweezer. Yeah, that happens. Suppose it's a customer's laptop, we have done something like that. You have to be in a position to fix it. But since we are doing it for the purpose of learning, I won't gonna doing that. So from this connector, there must be a pin which must be sent to ground, a pin which is carrying 3.3 from the startup chip ENE, which we have to send to ground in order to start the motherboard. So on, the motherboard is on. You can see big E, and you still have a working motherboard. So what we have learned so far? We still have a working motherboard, you can see. So what we have learned so far? We have learned that whenever you are carrying out a repair, don't do stupid mistake. It can cost you. Like in this, we broke this cable. If it's a customer's laptop, you'll be forced to fix this, and that will take your time. Or if you can't fix this, you'll be in big trouble with the customer. And also, on the issue of replacing coil with a wire, because a coil has a zero resistance. If you put a multimeter on the diode mode, a coil is beeping, you see 0, 0. Even if we take this one, which is off the motherboard, same thing. So, based on the theory that this is a wire, it's just passing some voltage in current, I said let's eliminate the coils for the CPU and replace with the wire, but it's not working because those wires can't carry enough current to the CPU. So those are the faults that you are most likely to see on laptop motherboards. In most cases, you are fixing only the power issue, but other issue you can't fix. Same if we simulate the RAM, there will be no voltage for the RAM. It will come on with no display. If you simulate the GPU, if there is no voltage on the GPU power supply, it's coming on with no display. And the other faults, like maybe the fan is not spinning. What I'm doing on the fan, we have 3 wires. We have the ground and the plus and the middle pin, which is going to the temperature sensor. Huh? So what I would do, if the fan is good but not spinning, I'll just reroute this fan to either 3.3 or 5 volts power supply. Huh? And you might have problem with the connectors. The connectors can die, like this connector for the screen can break up. Other connectors for the keyboard, for what can break up. But in most cases, the common faults, ceramic capacitors, they are getting on faults on many motherboards. The E.C chip is dying because the 3.3 always is always on, even if your laptop is off. So obvious, if something is carrying some power each and every time, the chances of that power supply to die is so high. So we're having mostly problem with the 3.3 volts power supply. Obvious other things like the USB ports, because the customer they are playing, they are breaking the USB ports. Yeah, you can replace the USB ports, or if you don't have voltage, maybe we have the problem with the driver, or we have a problem with the switching MOSFET for the USB. In our case, is this one, which is switching 5 volts to the USB. So at least I've done my part of explaining how motherboards are working. We try to simulate some faults to see how motherboard is behaving. And of course, we have other issues with the charging circuit. The battery is not being detected. Maybe you have the problem with the BQ chip. You have the problem with the E.C chip. Can be the firmware from the E.C chip can be corrupt, especially on new models of laptops. Can be corrupt, and the E.C chip is not communicating with the BQ chip. And yeah, it can happen to have like miscommunication between the E.C chip, between the E.C chip, the BQ chip, the BIOS, and the CPU. Now we are powering the motherboard for the last time before we. I can see on my OBS it's now more than one hour explaining how things works. On. The motherboard is on. It's taking 900, and we have big E, and we have display. Everything is working fine. So that's the thing. That's the thing. That's the thing about motherboards. Hopefully everyone understands how you can fix various faults, how you can detect faults, what are the causes of different situations, how the motherboard is reacting on different situations, on a short circuit, when some power rails are missing. Yeah, I think this video is about everything related to faults on laptop motherboards, yeah, and how you can trace and fix them. See you on the next one. Bye bye.